Hello, Psych 299 statistics students. This is Larry Hatcher. This is part 2 of my video on part 250 chi-square test of independence. In part 1 of this video, I talked about chi-square test of independence, talked about some other non-parametric procedures as well, but spent the vast majority of the time talking about the chi-square test of independence. Basic concepts: what does a cross-tabulation table look like? What's the no effect value for the chi-square test? How do we determine whether it's significant? What are the indices of effect size that we typically would use in the same kind of study where we would analyze the data with the chi-square test of independence? We're now at part 2 of the video, and here in part 2 I'm going to set up exercise 250.7 chi-square test of independence. This exercise begins on page E95. If you're following along, it'll be in Appendix E toward the back of your course pack. Begins on page E95, goes on for many pages. Exercise 250.7, chi-square test of independence. How female characters differ from male characters in popular G-rated movies. I'm going to talk about the setup of this exercise, fictitious study that leads to it, and I'll identify the specific items that is going to be assigned to the students in my class. As is the case with a lot of my exercises, there's a zillion items that could be assigned, but there's just the subset that'll actually be assigned. I'll talk about which subset when we get toward the bottom of it. So, beginning on page E95 in the course pack, exercise 250.7, chi-square test of independence. Let's skip the overview and dig down into the investigation itself. This is, as is the case with most of my exercises, it's fictitious data, fictitious results, but it is inspired by an actual investigation. See the reference section to this exercise to find the reference for the actual investigation that inspired it. Our fictitious investigation. Dr. O'Day is a fictitious faculty member of the psych department at a large university. Works part-time at the university's Statistical Consulting Center. Today, she's meeting with Dr. Green, faculty member of the university's Department of Communication. Dr. Green needs some guidance in analyzing data and interpreting results from an empirical investigation that he's just completed. In a study, a panel of judges watched 120 films and classified the characters portrayed in the films according to a number of criteria. Selected movies were the 120 top-grossing G-rated films released from 1985 to 2008. When you think G-rated films, think Disney for the most part, although it's not exclusively Disney. The judges watched these 120 films, classified most of the characters in the film according to the traits they displayed. These included things like the character's gender. Was it a male character or a female character? Character's apparent age, the character's relationship status. Was this character single, married, or what? The character's occupation. Dr. Green wants to understand whether there are systematic ways in which female characters tend to differ from male characters in these films. Were the female characters more likely to be young compared to the male characters? Were they more likely to be single? Were they more likely to have occupations that have traditionally been viewed as feminine occupations, such as nursing and teaching? Panel of 40 judges watched the films, coded characters according to these variables. Analysis and results. The fictitious setup, by the way, is that Dr. Green's research assistant did the analyses. Dr. Green is not sure he knows how to make sense of the results of the analyses, so soliciting help from Dr. O'Day in interpreting the results. So Dr. O'Day skimmed the results, was pleased to see that the graduate students seemed to have done everything correctly. She noticed that the assistant computed two statistics to use as an index of effect size: the phi coefficient, symbol phi, and also Kramer's V. Now, I hope you recall those statistics from part 1 of my video series on the chi-square test. Dr. O'Day therefore located a table that provided Jacob Cohen's criteria for interpreting these statistics. Relevant criteria are summarized in table 250.7.1. You'll remember Jacob Cohen. His name came up many times in our class. He's written a number of books and articles, been very influential in statistics, in particular in psychological sciences. He has generated benchmarks, criteria that can be used to interpret effect size. Cohen always recommended that anytime you're doing an investigation and compute an index of effect size, you should compute the index you got in your study to the indices that were obtained by other researchers when they investigated similar variables in previous studies. When that's not possible, he gives some last resort benchmarks that you might use in interpreting your effects, and that's what we're going to use in this exercise. First of all, under index of effect size, here we have the symbol for the phi coefficient. Interpreting phi coefficient is simple, according to Cohens Guidelines, because criteria are going to be the same as the criteria for the Pearson R correlation coefficient. You call it a small effect if it's bigger than plus or minus 0.10. Call it a medium effect if it's bigger than plus or minus 0.30. Call it a large effect if it's bigger than plus or minus 0.50. Things get more complicated, however, if you did chi-square and you have something bigger than a 2 by 2 table. You recall that you can use the phi coefficient, or rather the phi coefficient, if it was a 2 by 2 table. But if it's bigger than a 2 by 2 table, you should probably instead use Kramer's V as your index of effect size. And the specific criteria for labeling something as small effect, medium effect, large effect depends on the size of the table. Notice I've got more than one row under Kramer's V. If k is equal to 2, use these benchmarks in interpreting Kramer's V. If k is equal to 3, use these benchmarks in interpreting Kramer's V. What is he talking about? Well, take a look at the note at the bottom of the table. I've highlighted this last sentence or two. Kramer's V is a generalized version of the phi coefficient. Kramer's V is appropriate for 2 by 2 tables and larger tables. Here in this table, K represents the number of rows or the number of columns in the contingency table, whichever is smaller. So here you will use as K the number of rows in your table or the number of columns in your table, whichever is smaller. For example, if you have a 3 by 2 table, 3 rows and 2 columns. Well, 2 is the smaller of the two values, so you would look at the values that are in K is equal to 2 and use the benchmarks there. What if you had a 4 by 3 table? If it's a 4 by 3 table, 3 is the smaller of those two numbers, so you would look in the row that is labeled K is equal to 3 and use those benchmarks. Notice, as the table gets bigger, the benchmarks get smaller. As the table gets bigger, you don't have to have as big a value of Kramer's V in order to interpret a result as being small or medium or whatever. For example, if it was a 2 by 2 table, then you'd call it a small effect if the Kramer's V statistic was 0.10 or bigger. But if you had a bigger table, where the smaller of the number of rows and the number of columns is 3, let's say you've got a 4 by 3 table, you would look in this row and see the Kramer's V only has to be as big as 0.071 to call it a small effect. So the benchmarks get easier to reach as the table gets bigger. That's the way it works with Cohen's criteria for interpreting Kramer's V. You'll come back and look at these benchmarks as you do the exercise. There's some items in the exercise which require that you take a value of the phi coefficient or Kramer's V and interpret it according to these benchmarks provided by Cohen. Now, let's look at some of the results that Dr. Green got in his fictitious investigation. I'm on the bottom of page E96. Page E96 toward the bottom, we have this. Total number of male versus female characters. In this study, a character was defined as an individual that spoke at least one word of dialogue in the movie being viewed, because the number of male individuals and female individuals is approximately equal in most societies, and by that I mean real-world societies. Dr. Green made the following research hypothesis. Research hypothesis 1, number of male characters will be approximately equal to the number of female characters. Well, that's his prediction. I suspect he set that up as a straw man to be knocked down. Let's see if the results do knock it down. The results show that there was a total of 3,548 speaking characters in the 120 movies. Of these, 2,626 were male characters, 922 were female characters. These frequencies are illustrated in the next figure. We go to page E97, and we have figure E250.7.1. Number of characters in the top grossing G-rated films as a function of gender of the characters. Error bars are 95% confidence intervals. Look at this. It looks like in these G-rated movies, there were a lot more male characters than female characters. Now, I don't have any inferential statistical analyses of these results, but I believe I've got an item in the exercise that requires that you look at these bars in this bar chart and make some decisions about whether these results are consistent with Dr. Green's hypothesis, research hypothesis number 1. So there is our first bit of results on page E97. I am still on page E97. Let's scroll down some. Now we're going to get into some hypotheses that will involve chi-square test of independence. Gender and the relational standing of the character. It's possible to code some of the adult characters in the movies according to their relational standing. That is, whether they were single, married, in a serious committed relationship, versus divorced or widowed. Prior to gathering the data, Dr. Green had stated following a research hypothesis. Research hypothesis 2, there'll be a significant, substantial relationship between gender of the characters and relational standing of the characters. Compared to the male characters, female characters will be less likely to be single, more likely to be married or in a serious relationship. That's his prediction. What did the judges see when they looked at these 120 G-rated movies? To investigate this research hypothesis, Dr. Green's research assistant created a contingency table, which is another term for cross-tabulation table. In my lecture, I typically call it cross-tabulation table. The research assistant created a contingency table for character, gender, and relational standing variables. He also computed chi-square test of independence for the two variables. Results are presented in the next table and in the next figure. We go to page E98, and we have table 250.7.2, relationship between movie character gender and relational standing of the character. Now, this is cross-tabulation table. I don't have all the lines that appeared in the tables that I showed in my lecture, but it's going to be the same basic setup. First of all, notice the columns of the table. The columns of the table represent gender of the characters. This column, we have information for male characters. In this column, we have information for female characters. The rows of the table, the horizontal rows, represent relational standing of the character. This row represents characters that were single. This row represents those that were married, serious relationship. This row represents those that were divorced and widowed. Let's take a look, first of all, at the column that represents male characters. Now, I've got percentages, but we'll ignore the percentages for the moment. Instead, focus on the column headed in. That's where we see the raw frequencies. It looks like there was 279 male characters who were single. There was 119 that were married and in a serious relationship. There were 13 that were divorced and widowed. Now, that's when you look at the male characters. What do you see when you look at the female characters? Of them, 56 were single, 83 were married or in a serious relationship, 5 were divorced or widowed. So, this is our cross-tabulation table. Is there a relationship between the relational standing of the character and the gender of the character? Well, to determine whether there's a relationship, you compute chi-square test of independence. The results from our chi-square test of independence is in this section of the table. Under the heading chi-square, we have our obtained chi-square value. Under DF, we have degrees freedom for the test. Under P, we have the p-value, probability value for the chi-square test. I didn't talk about p-values in my lecture. In my lecture, I talked about the critical value approach to determining whether you have a significant chi-square statistic. That's the approach where you compute your obtained chi-square and compare it to a critical value of chi-square that you find in a table. That's not the way we typically do significance tests these days. Typically, we analyze it with a computer program. Computer program, among other things, gives us a p-value for the statistic. Here, the p-value is less than 0.001. Is that statistically significant? I'll leave it to you to decide. Skim back through your notes on previous lectures. How small does a p-value have to be for us to call it statistically significant? And that'll be your call based on my lecture notes. And not in the lecture on chi-square, but in previous lectures. And finally, always want an index of effect size. Good index of effect size to use whenever you're computing chi-square is Cramer's V. In part 1 of this lecture series, you heard me say that I'm a big fan of Cramer's V. Cramer's V is 0.27. Well, how do we interpret that? Is that a small effect? Is it a medium effect? Or what? I leave it for you to decide that. That's where the table of benchmarks from Jacob Cohen will come in handy. A table of benchmarks that I went over earlier. Now, presenting statistics in table form like this is perfectly fine. A lot of us are visual readers and we prefer to see things presented as a figure. So on the same page, still on page E98, scroll down and we have a figure that illustrates the frequencies that we had just looked at. What does the title say? Frequencies for relational standing of characters as a function of gender of character. Error bars, 95% confidence intervals. This cluster of bars represents frequencies for male characters. This cluster of bars represents frequencies for female characters. What's the difference? What does a white bar represent? What does the shaded bar represent? Ah, here it is. Relational standing of the character. White bars represents the number of people that were single. The somewhat dark bar represents those in a married serious relationship. The darker gray represents those that are divorced and widowed. I'll leave it to you to look at these bars and get a sense of what does the trend seem to suggest. So, one set of results that you're going to focus on when it comes to the items, the exercise items that we'll see later in this exercise, is relationship between relational standing of the character and gender of the character. Let's move to another topic and another hypothesis and another set of results. I am still on page E98. Toward the bottom of page E98, we have this. Gender and primacy of the character's role. This is a term I had not run into before I read the actual real-world article that my fictitious exercise is based on. Gender and primacy of the character's role. What do they mean by that? In this context, primacy refers to the relative importance of a specific character's role in a film. A primary character is a lead character, the main focus of the film. Think of Dorothy in The Wizard of Oz. That's primary character. Secondary character doesn't get as much screen time as primary character, serves as more of a supporting role. Think of Dorothy's Auntie Em back in Kansas. And finally, a tertiary character is a bit part. Think of the Munchkins in The Wizard of Oz. All of the characters in the movies were coded to indicate whether they were primary, secondary, or tertiary characters. Dr. Green made this prediction. Research hypothesis 3. There'll be a significant, substantial relationship between gender of the character and primacy of the character's role. Compared to male characters, female characters will be less likely to be primary characters, more likely to be secondary or tertiary characters. To investigate this, Dr. Green's research assistant created a contingency table for character gender and primacy of the character's role, computed chi-square test of independence for the two variables. Results are presented in the next table in figure. Let's look at the table. Table E250.7.3. Relationship between movie character gender and primacy of the character's role. Once again, the columns represent gender of the character. We have male characters here, we have female characters here. But the rows represent a different variable, primacy of the character's role. This row represents primary characters like Dorothy. This row represents secondary characters like Auntie Em. And this row represents tertiary characters like the Munchkins. What do we have? When we look at the male characters, We had 160 primary characters, 788 secondary characters, 1,638 tertiary characters. With females, it was 56 primary, 295 secondary, 571 tertiary. Well, what does this look like? Oh, and of course, we've got the usual statistics. Here's chi-square statistic. We want to find out, is there a statistically significant relationship between gender of the characters and the primacy of the character's role? Here's the chi-square statistic that tests that null hypothesis. 2 degrees of freedom. Here's the p-value. Well, is it statistically significant? How should we interpret this p-value? Thumb back through your notes from previous lectures and you'll see whether this is statistically significant or not. Significant or not, we can always look at the index of effect size. Kramer's V is equal to 0.02 in this case. Well, the table is kind of difficult to visualize. Wouldn't it be easier on the reader if we turn this into a figure? It would. Let's look at a bar chart that illustrates the numbers that had appeared in that table. Bar chart is at the top page, E100. The X variable is the same variables before, gender of the character, male versus females, but the cluster variable is going to be a different variable. It's now going to be primacy of the character's role. The white bars represents the number of people that were primary characters. The semi-shaded bars were the number that were secondary characters, and the darker shaded bars represent those that were tertiary characters. Well, look at the trends. The trend about the same for males as it is for females. Maybe the chi-square statistic and Kramer's V would help you make that determination. So there's a second research hypothesis we're going to investigate, one that involves primacy of the character's role. There's more. We're going to skip. I have a note to myself. As is the case with a lot of my exercises, I've got way more results than any one student could reasonably do in a reasonable period of time for an exercise. So we're going to skip a bunch of information, and we're going to skip to page E103, where we come to another set of results that I do want you to worry about. E103. Here I am, E103. Was there any setup for this? Oh, this is where it begins. Oh, E103 is where the questions begin. There's a bunch of results here where we're not going to focus on those results because they lead to exercise items that I'm not assigning to you folks for this particular discussion exercise and online quiz. Let's go to the questions that you do need to worry about for the current discussion exercise and online quiz. If we were meeting face-to-face, I would have you go into small groups and you would work on these items in small groups. Since we're not meeting face-to-face, you're going to have to work on this on your own. You should come up with an answer for each of these items before you go to the Canvas quiz, because you have a time limit of just 30 minutes for the Canvas quiz. The items on the Canvas quiz will be multiple choice format. There'll be a subset of these more open-ended items that you're going to worry about right now. I'll go over these to make sure that they're crystal clear. One of the items that will be assigned for this discussion exercise is factual item 1. It goes like this. Dr. Green's research hypothesis 1 stated the following. Research hypothesis 1 said, the number of male characters will be approximately equal to the number of female characters. In these 120 G-rated movies that were coded by the research assistants, was there support for this research hypothesis? Research hypothesis 1, number of male characters be approximately equal to the number of female characters. I have a bunch of sub-questions to break this down step by step. Sub-question A, which bar chart illustrates results that are most directly relevant to this research hypothesis? Thumb back through the exercise, find the bar chart that's relevant. Sub-question B, what's the total number of male characters in these movies? C, what percent of characters were male characters? Now this exercise does not provide this percentage. You must compute it, and you've got enough information, you'll be able to compute it. Sub-item D, what was the total number of female characters in the movie? E, what percent of characters were female characters? Once again, the exercise doesn't give you the percentage. You've got to compute the percentage. And finally, sub-question F. Are the percentages that you've just computed generally supportive of Dr. Green's research hypothesis? This article does not provide a significance test or an effect index directly relevant to it, so you're just going to have to base your answer on the percentages that you've just computed in responding to the first couple of items. So, item 1, you're kind of on your own. Find the relevant results, do some hand calculations, come up with your answers to these items. Item 1 is one of the assigned items for this discussion exercise. Item 2 is not. Notice it's not highlighted, so we're going to skip over item 2. But item 3 is highlighted, so item 3 will be assigned. Item 3, it's on page E104. Dr. Green's research hypothesis 2 states the following. Research hypothesis 2. There'll be a significant and substantial relationship between the gender of the characters and the relational standing of the characters. Compared to the male characters, female characters will be less likely to be single, more likely to be married or in a serious relationship. Table E250.7.2 reports results from a chi-square test of independence relevant to this research hypothesis. State the statistical null hypothesis that was tested by this chi-square test. Heads up, this exercise does not give you the statistical null hypothesis that was tested, but in part 1 of this video set, I indicated that the statistical null hypothesis that's tested is pretty much the same anytime you do a chi-square test of independence. Thumb back through your notes for part 1 of this video set, and you will find the statistical null hypothesis is just about always tested with a chi-square test of independence. Item B was the obtained value. What was the obtained value of the chi-square test of independence? That is, what was the chi-square statistic, the obtained chi-square statistic? Item C, this is what a lot of readers are going to be most interested in. With alpha set of 0.05, was this chi-square test statistically significant? How do you know? Well, wait a minute. In part 1, you said we have to use critical value of chi-square. Well, that's true. I taught that approach in part 1. But in this exercise, I gave you the p-value for the obtained chi-square statistic. Anybody in my class should be able to look at a p-value and know whether the results are significant or not. The answer may not be in part 1 of this video, but thumb back through lectures on previous parts in our course, and you'll remember how to make sense of a p-value. Item D, what statistic was used as an index of effect size for this analysis? Was it the phi coefficient? Was it contingency coefficient? Was it something else? Was it some other index of effect size? So what was the statistic that was used as an index of effect size? What was the obtained value of this statistic in this analysis? According to Cohen's criteria, does this index of effect size from the preceding item, does it represent less than a small effect, medium effect, or a large effect? And yes, you will need one of the tables that was presented earlier in this exercise to answer this item. Item F, part of research hypothesis 2 predicted, compared to male characters, female characters will be less likely to be single, more likely to be married or in a serious relationship. Are the results in table E250.7.2 generally supportive of this hypothesis? Defend your answer, clearly indicating which specific information from the table is most relevant to your answer. And finally, item G. In summary, are the results in table E250.7.2 generally supportive of research hypothesis 2? Defend your answer. So, item G, all of the sub-items here focus on one research hypothesis 2. There's another item that you need to worry about for this exercise, and that is exercise item 4. It's going to seem familiar. Exercise item 4. Dr. Green's research hypothesis 3 stated the following. Research hypothesis 3. there'll be a significant, substantial relationship between gender of a character and the primacy of the character's role. Compared to male characters, female characters will be less likely to be primary characters, more likely to be secondary or tertiary characters. Okay, item A. Table E250.7.3 reports results from chi-square test of independence relevant to research hypothesis 3. State the statistical null hypothesis that was tested by this chi-square test. You won't find it in this exercise. You will find the null hypothesis in my lecture notes from part 1 video. Item B. What was the obtained value of this chi-square test of independence? Yes, you will find the obtained chi-square statistic in this exercise. With alpha set at 0.05, was this chi-square test statistically significant? How do you know? What specific result did you have to look at to make sense of it? Item D, what statistic was used as an index of effect size? What was the obtained value of this statistic in this analysis? Item E is related. According to Cohens criteria, does this index of effect size from the preceding item represent less than a small effect, medium effect, or a large effect? Item F, part of research hypothesis 3 predicted, compared to male characters, female characters will be less likely to be primary characters, more likely to be secondary or tertiary characters. Are the results in table E250.7.3 generally supportive of this hypothesis? Defend your answer, clearly indicating which specific information from the table is most relevant to your answer. And then finally, item G, put it all together. In summary, are the results presented in table E250.7.3 generally supportive of research hypothesis 3? Defend your answer. All right, item 4 in general is about the big picture. Look at a whole bunch of statistical results relevant to this one analysis. Tell me about the specifics of it, and also I want you to be able to step back and tell me the big picture results. We skip item 5. Item 5 is not assigned. In fact, item 6 is not assigned. Item 7 is not assigned, but item 9 is assigned. Here I label it a discussion item, but in truth it is objective enough that this discussion question could wind up being one of the multiple choice questions on the Canvas quiz that you're going to do. I'm on page E106. We're looking at discussion question number 9. Discussion question 9. Current study investigated relationship between character gender and 4 other categorical variables. Relational standing of the character, we talked about that. Primacy of the character's role, we talked about that. Age of the character, we didn't talk about that, but it's in this exercise. Look at, there's a section of the previous exercise that gives you a table and a figure that indicates results for this relationship between gender of the character and age of the character. And gender orientation of the character's job. Didn't talk about this, but there is a table and there is a figure that illustrates results relevant to this relationship between gender of the character and gender orientation of the character's job. Okay, of these 4 variables, which of these variables displayed relatively strong relationships with character gender? Which variables displayed relatively weak relationships with character gender? Which specific results from each analysis will help you make this decision? Hint, in a given table, you should look at just one statistic. You should not compare percentages or anything complicated like that. In each of the preceding 4 tables that are relevant to these 4 variables, what's the one statistic that you should look at that will allow you to determine this variable showed a strong relationship with gender, this variable showed a weak relationship with gender, and so forth? What is that one statistic you need to worry about? To put it all together, just answer the following 4 questions. This puts it in more systematic terms. Sub-item A. Which variable displayed strongest relationship with character gender? And what statistic did you review to answer this question? Which variable displayed second strongest relationship with character gender? What statistic did you look at to answer this? which variable displayed third strongest relationship with character gender, and which variable displayed the weakest relationship with character gender. Once again, what statistic did you look at in order to answer this question? So item 9 is another big picture item. We have 4 different variables here that may or may not be related to character gender. Which variable showed the strongest relationship with character gender? Which showed the next strongest relationship, and so forth. Now, on my handout, I had highlighted item 10, but in fact, item 10 is not going to be assigned to you folks. In fact, I believe that's the last of my items, but I do have a few more things to say. If you're a student in my PSYC 299 class, and I can't imagine why you'd be watching this video if you were not a student in my PSYC 299 class, I wanted to say some specifics about this exercise you're about to do, and I'm actually going to make a special offer related to this exercise, an offer that I did not make with respect to previous exercises. What could I be talking about there? First of all, this kind of formalize and put in black and white what you're going to do. Exercise 250.7, chi-square test of independence. That's the exercise that I've spent the last 30 minutes talking about. All students will complete just the following subset of items. These are the items that I just went over. Everybody will do item 1, item 3, item 4, and item 9. Those are the only items you'll do, those 4 items. You will not do item 10, even though I had highlighted it on my handout. You don't need to worry about item 10. This will result in a Canvas quiz, as is just about always the case with my discussion exercises. In this case, the Canvas quiz will be called VQ 250.7.1 chi-square independence. As is the case with most of my Canvas quizzes, it'll be 5 multiple choice items worth 2 points each. 5 multiple choice items will be multiple choice versions of the open-ended questions that we described up here. As has been the case with my exercises ever since we went into lockdown, you'll have a 30-minute time limit, but you'll be allowed 3 submissions. If you don't get 10 out of 10 on the first submission, you've got 2 more submissions to try it. As is the case with all my exercises, this will be available for 1 week. It'll be available until 11:59 p.m. Saturday, April 25. That is 1 week from the day that I'm releasing this video. Here's my special offer. You might recall that over the past couple of weeks, I've encouraged students to submit suggestions for how I can improve the online version of this PSYC 299 class. I've never taught it online before, and so I'm eager for ideas on how to do things better. At least one student said, there's a problem with the exercises now that we've gone online. Back when we were meeting face-to-face, we would do the exercises in class in small groups. A group would pitch their answers to you, Dr. Hatcher, and you, Dr. Hatcher, would tell us whether those answers were correct or incorrect. So by the end of the class meeting, everybody walked away with the correct answers to all the items on the discussion exercise. And we don't have that now. Now that we've gone online, we just do the exercise on our own, and we don't know whether we have the correct answers or not before we log into Canvas and do the Canvas quiz. This student suggested, why don't you offer to share the correct answers to the discussion exercise as long as the student shows evidence that they gave good faith effort at the exercise? So this is my offer in order to make things more like they were before when we were meeting face to face. Would you like to see the answer key to this exercise before you actually go into Canvas and do the Canvas online quiz? If you'd like to see the answer key that has all the correct answers for sure, then do these exercise items that I've just talked about, put it in the form of an email, and email your answers to me by 11:59 p.m. this Thursday, Thursday 23rd. I'll look it over, and if it looks to me like you gave good faith effort to the exercise, I will email back to you the correct answers to those assigned items. So yes, you'll have the correct answers just as you would have had the correct answers at the end of the class period when we did the discussion exercise face to face. So that's my special offer to take some of the sting out of these exercises and make it a little bit more like it was before. What do you mean by good faith effort? Well, give me an answer that indicates this is the answer I came up with. Just say a few words about how you came up with that answer. Give me just enough information to convince me you took it seriously. You really tried to answer the questions. If you convince me of that, then I'll send you my answer key, and you'll definitely have all the correct answers before you log into Canvas and do the quiz. So that is the setup. Soon after this video is posted, you'll see that an exercise, a Canvas quiz called VQ 250.7.1 chi-square test of independence will appear in Canvas in the quizzes section. It'll be worth 10 points total. It'll be available for 1 week, as is usually the case. You don't have to take me up on my offer about emailing me your answers, but if you choose to do so, email me your answers by 11:59 p.m. this Thursday night, and I will send back to you the correct answers. You don't have to wait till Thursday night. You can email me your answers whenever you come up with the answers. That's it. That's part 2 of my video set on the chi-square test of independence. Have questions about any of this? Shoot me an email, and keep your eye out for future emails from me where I'll talk about the next activities and the next step in our PSYC 299 class.